Yeah, that's a question that we always get when we say we want to re-wet the peatlands. And people have heard a bit about these things, and then they say, oh, but if you do that, then you get methane out of the site. And methane is a super strong greenhouse gas, so what are you doing? You are ruining the climate. And then we say, no, we are not. Because before we do the re-wetting, there's a whole shitload of CO2 coming out of it. Yeah? From a drained peatland, say, used for grassland, 25, 30, 35 tons of CO2 per hectare per year is coming out of it. If we re-wet that, this is a simple microbial process. It is based on oxygen penetrating the peat, and you get microbes eating away at the stuff, and it goes up in the atmosphere. If you raise the water table, you create anoxic conditions, there is no oxygen entering the peat and it stops. It's simple microbial process. Bring the water table to the surface, zero CO2. And yes, then there is methane coming out. And methane is a very strong greenhouse gas. But for such a site where the water table is at the surface for the entire year, on average, I would say for Europe, 250 kilograms. I'm talking kilograms. Remember, with the CO2 I was talking tons. That's 1,000 kilograms, yeah? And here it is 250 kilograms of methane per hectare per year that's coming out of it. And then there are plenty ways of trying to compare these things. And most of you will have known of a thing called global warming potential, that you say, yeah, but methane is 28, 23, the number changes, the latest one is 27, 27 times worse than CO2. But this measure is a nonsense measure. It was published in the first report of the IPCC on the state of the climate, where they said, yeah, we have these different gases and we would like to compare them, but it is very difficult because some stay long in the atmosphere and very strong, and some stay only short in the atmosphere and are weak, or the other way around, and we get all these mixes, and it is difficult to compare these things. We should try and develop something to compare these things, is what IPCC wrote. There is this thing called global warming potential, but it is far from ideal, but we present it here as a placeholder to inspire future measures. And then politics said, aha, there it is, we use that. So now, politics, in the UNFCCC, you see countries pledging in tons of CO2 equivalents, which is actually this measure. Yeah? This measure, I can explain that. Should I explain what it is, how it works? Do you want to know?
Yeah.
Yes.
What this measure is you throw 1 kilogram of CO2 into the atmosphere, and you throw 1 kilogram of methane into the atmosphere. Yeah, you don't see it, I'm talking about air here. Huh? And you do that in year 1. And then you don't do anything in terms of throwing stuff into the atmosphere, but you measure the effect of this 1 kilogram of each of the gases on the warming effect in the atmosphere. These molecules are in the atmosphere, the radiation from the sun that comes to the earth and bounces back is stuck in these molecules up there, and this is what warms our planet. Methane does that much better than CO2. It's just that methane stays in the atmosphere on average 11.9 years, say 12 years. Yeah? So that means, but that's not in this measure. Just there I see, okay, it is in the atmosphere in year 1, and then it goes out, and I have this warming effect, and then I simply, what I do for year 1 to 100, I count what the warming effect is of the molecule that I put in the atmosphere in year 1. What is the effect of this one molecule in year 2, in year 3, 4, 5, 6, 7, 8. But the methane is not in the atmosphere after 12 years on average. So actually you're then calculating plus 0, plus 0, plus 0, plus 0, plus 0, plus 0. And then in year 100 you say divide the effect of methane by the effect of CO2, and there you have this 27 or 28 factor. But that is not how the world works. This is a site that now emits every year 250 kilograms of methane. And before that it was a site that every year would emit 30 tons of CO2. So then you make a measure and you say, I throw 1 kilogram of methane into the atmosphere in year 1. I do the same in year 2, and 3, and 4, and 5, and 6, until I get to year 13, and then this kilogram from the first year is gone, on average. Huh? Meaning that I'm stuck with 12 kilograms in the atmosphere in year 12, but also in year 13, and in year 14, and 15. it doesn't change anymore. I get a stable amount of methane in the atmosphere, meaning a stable warming effect of this methane in the atmosphere. For the CO2, this is not the case. The CO2 goes into the atmosphere and on average stays there. Yeah, there is no average. It can stay there for thousands and thousands of years. Yeah, it's still there. And meaning that if I throw 30 tons of CO2 in the atmosphere every year, then I get an increasing warming effect. It becomes larger and larger and larger and larger. Yeah. So I'm dealing actually, if I compare the two, yeah, thank you. If I compare the two, I'm dealing with methane going up and then being flat in terms of warming effect. And CO2, it goes up and up and up and up and up. Yeah. And it is indeed so that initially 250 kilograms of methane are worse for the climate than 30 tons of CO2. And I would say that it takes maybe 20 years, and then the wet situation becomes better than the dry situation, so the drain situation, and it becomes each year better, because the effect of methane will not increase, and the drain, when it had been drained, it would be the worse, worse, and worse. So you see that over the longer the period you look, the better the wet side becomes compared to the dry side. Yeah? No. And the thing is, and that is really important. We see now that politics has taken the science of IPCC without really understanding it and defining targets, political targets, in terms of CO2 equivalents, in terms of a nonsensical measure. Now, I have done calculations and where we rewet all the peatlands of the federal state we live in, yeah, by 2040, because the politics says, yeah, by 2040 we want to have zero. And then we say, that's nice. Did you know that more than 1/3 of the emissions of your federal state are from drained peatlands? And then they said, oh, then what do we need to do? And we said, you have to re-wet them all. So all the peatlands have to be wet by 2040. But then of course they say, yeah, can we also not have a sink in these peatlands? Because sinks are even sexier. They say, of course we can calculate that. We can develop that. By 2040 we will be able to establish a sink of 1 ton per hectare on each average hectare of rewetted peatland. We will be able to do that. And we will even be able to reduce methane emissions from rewetted peatlands because we are smart people and we are inventive. And then you calculate that, and then you see that in this pathway, in 2030, I have a CO2 sink. And the CO2 sink stables off and remains stable CO2 sink. Yeah, from 2030 onwards. I even have a carbon sink. Yeah? CO2 in, methane out, and then two together, it's carbon sink. It's a carbon sink, yay! Global warming potential starting 2030, negative. All targets have been reached. It's just that the site remains warming until 2130, so 100 years it remains warming, and it becomes cooling only after that. A sink is cooling, but you have to keep the methane in mind. And you have to keep in mind that methane does something different in the atmosphere than what CO2 does in the atmosphere. Yeah? And so, of course, then you say, oh, but if it is not cooling, then I don't need to re-wet it. Yes, you do. Because if you are then, in 2130, you have a cooling system, and otherwise you would have had much, much more heat and warmth of the CO2 into the atmosphere. And that is why peatlands must be wet. And we must act, and we must act now. Yeah? The longer we wait, the more CO2 goes into the atmosphere, the higher the warming effect of the drained peatlands will be. Yeah? Now who's next?